So in today's lesson, we're going to be having a look at free radical substitution. This process takes part through 3 steps, and the first step is the initiation step. So it makes sense, initiation, that's going to initiate our reaction, get things started. So we're starting off in this section by looking at radicals being produced from molecules. In order to initiate this reaction, we need to have radicals being produced, and then they can go on and react further in the propagation step. So these radicals are produced from molecules, and the molecules we're going to be looking at are the halogens, so chlorine, bromine, fluorine, etc. And this happens in the presence of UV light. So we need that high energy ultraviolet light in order to break that covalent bond. It's homolytic fission, so what happens is each of the electrons in the bond go back to the original atom that they started with. So we have 2 chlorine radicals produced from a chlorine molecule. And a chlorine radical is just a chlorine atom. And so you'll see when we write the equation to show what happens when we have this halogen in the presence of the UV light breaking apart there. When that bond breaks, the radical that we produce is represented by the X or the Cl, whatever it may be, with this dot on it. So that dot there, that radical dot, is representing the unpaired electron. So we call this a free radical, and it's called a free radical because it has an odd number of electrons, so it has an unpaired electron. So a species with an unpaired electron is our radical, and we represent that radical with that dot. So if we're going to write this kind of equation for a specific example, we could have chlorine, say, we'd have our Cl2, and then we simply have that arrow, ultraviolet light is required, and we would make 2 chlorine radicals. And that's what we have at the end of our initiation step. We produce these chlorine radicals, which can then go on to react further in the subsequent steps. So what we have here is our next step in our free radical substitution mechanism. This is the propagation stage. In the propagation stage, we are taking a molecule and a radical, and we're making a different radical and a different molecule. So the radical that we have would be a radical that has arisen due to the initiation step. So we've got that radical, which remember is a species with an unpaired electron. So that's what's happening in this propagation stage. That radical is reacting with a molecule. It will produce a new radical, which essentially is that molecule that has lost an atom, and then a new molecule where that atom has been transferred across to our original radical. And these come in pairs, as we'll see in a second. So in a more general kind of example, you could have an alkane. It would react with the X radical that we had from earlier, say a chlorine atom, produces an alkyl radical, which is just my alkane which has lost a hydrogen, and then I have HX. So we've just had a swap there really of the hydrogen from the alkane onto the radical. That alkyl radical is very reactive still, so that can then go on to react further with, say, some X2 that is still present. And this will then produce a halogenoalkane. And that's really the purpose, in a way, of this free radical substitution. It's a way we can think about the synthesis of a halogenoalkane through this process. And we also produce that radical back again. So it's propagation because we've still got that radical there, that X radical. We can look here at the molecules, so just a bit more specific. So if we had methane, we get a methyl radical. Look where the dot is on the methyl. So on the CH3 there, you can see I've put the dot next to the carbon, not on the other side. It has to be next to the atom that actually has the unpaired electron. Okay, and then if you take a look at our radical, so if we CL2, say, then that Cl2 or Cl will be reacting to make the HCl, and then underneath we'll specifically have Cl2. That will then go on to react with the alkyl radical that we had from above, and so therefore we would produce chloromethane and still the Cl radical. And then that proceeds and carries on as this chain reaction. And now we have our final step of the free radical substitution mechanism, and this is the termination step. So this is going to be the step that is going to stop this chain reaction proceeding. So lots of these steps can be happening at the same time. We can get different types of termination step. There's not just going to be one of these happening. You'll see some examples at the end. But what we are thinking about is, in general, we have two radicals coming together and they're making a molecule. So remember, the reason that the chain reaction continues is because the radicals are so reactive. So as soon as we produce a molecule, that molecule is relatively unreactive. So this is going to stop the reaction, and we will see things either slowing down because there's not so many of these steps happening, the propagation steps, or it will just stop completely. So this could be any two radicals. They can be the same, they could be different. And the example we would give in general, we've got the X. Remember, X is our halogen, so it's going to be chlorine, bromine, fluorine, something like that. And then the Y could be any other radical. So in this case, we could have the methyl, that would be my Y, and then I've got the chlorine as the X. It doesn't really matter. What we're making is the chloromethane, and that's unreactive, and so that's why it's a termination step. Other examples we could have here, we could have two chlorines coming together to make Cl2. So again, the Cl2 relatively unreactive in this situation, so therefore that's our termination step. And the same, we could have two methyl radicals coming together to make ethane, so that would be another termination step. So we've looked at the three stages of free radical substitution: initiation, propagation and termination steps. And so now we can consider that overall equation. So say we started with methane and chlorine, we would end up with chloromethane and HCl. We could look at an alternative example where we start with, let's say, methane and 4 chlorine molecules, or 4 moles of chlorine for 1 mole of methane, and in this case we will be looking to make carbon tetrachloride, CCl4, and 4 molecules of HCl. So we can see a bit of a pattern building up here in terms of the number of halogen atoms that we want to add to our original alkane, and how many halogen molecules are required, and how many of the HCl, HBr, HF, etc. will be produced. And so that pattern is that for every hydrogen atom replaced by X, where X is the halogen, then 1 molecule of X2 is needed, and 1 molecule of HX will be produced. And something else we can consider here is that we don't have to have an alkane at the beginning. We could start with a haloalkane, and you will see this in some exam questions especially, where they've started with something that already contains a halogen. So just look out for that, because you can have a haloalkane and then you can add further halogen atoms to that. So just be aware that that's a possibility. So such as in this example here, where we started with the chloromethane reacting with fluorine, so you can see that our product there contains the fluorine and also the original chlorine that we had. So those are our 3 stages of free radical substitution. We have the initiation stage, the propagation stage and the termination stage. And in the initiation stage we have molecules which are hit by that ultraviolet light. That's of the right energy in order to break that bond in order to produce radicals. Those radicals can then go on in a propagation stage to react with molecules to create further new radicals, different ones, and also different molecules. And that will happen repeatedly. That's why this is a chain reaction. And also at the same time, we can have termination reactions happening where the radicals that we've produced, either the new ones or the original ones, will react with each other in order to create molecules which are unreactive, and so that is our termination step. So you can see those 3 stages that we have. We've got that initiation step with the ultraviolet light on the molecules to make radicals. Then we have the propagation step where those radicals react with molecules to make new radicals. And then we have the termination stage where radicals react with each other to create molecules.